Hey everyone, this is the Cummingtonite Rockers, and this is our presentation on plastic pollution. So what is plastic pollution and why is it an issue? So everybody knows what plastic is, and plastic pollution is just the buildup of plastic waste of all kinds in our environments. And plastic pollution negatively affects pretty much all living things. An example right here is the sea turtle. As you can see, it's very, very sad because there's a lot of plastic waste buildup in its environment in the oceans, and it's killing off sea turtles. So we got to find a way to fix that. So current solutions and the issues that we have with them. So a big one is recycling. And the idea here is converting waste products into a material that can be reused and made into new items. And the issue here is that most plastic waste actually can't be recycled, and that's just not a very efficient way to solve this problem. So the next thing is reusable materials. And the idea here is to create materials that are traditionally intended to be single-use into stronger, longer-lasting materials that can be reused. The issue here, though, is higher upfront costs. Then finally, we have reducing plastic use. And the idea here is for consumers to use household reusable items, reducing their plastic usage, like reusable grocery bags. But the problem here is that falls entirely on consumers and not at all on big corporations that are actually producing the plastic. So while these solutions do help, our team thinks that we need a more efficient and effective method to solving plastic pollution, such as electrospinning. So electrospinning is an idea that's been around for a while, but it's now being re-engineered to transform plastic waste into polymer fibers that can be reused as other objects. So our team thinks that with a few adjustments, electrospinning would be a great ethical solution to plastic pollution.
My name is Colton C, and I'm here to present to you the electrospinning idea by the Cummingtonite Rockers. Here is the old macro version of electrospinning, where plastic waste, PET, PC, PS products are depolymerized into a solvent, which are then electrospun to create nanofibers. Here is the macro version. The syringe pump can contain multiple pumps or multiple syringes or a singular syringe, which this pump is then attached to a high voltage power supply between 5 to 60 volts. This process is then attached to a Taylor cone. The Taylor cone is what creates the nanofiber itself. With higher voltage, the thicker the nanosupply, or the thicker the nanofibers are, and the strength of the nanofibers. So then, as the nanofibers are being created by the Taylor cone, the drum collector will be spinning to collect all of the nanofibers. And as the nanofibers are created, they can then be worked into a plastic product, which then can be recycled and put through this cycle all over again. The issue is that plastic may not reach this process. So what our idea takes is new research from an NC State scientist where this super microorganism attaches itself to plastic. So what our idea is to take this microorganism and to put it into a solvent and be pushed through the syringe pump to then create nanofibers that contain this microorganism.
Colton was saying, NC State researchers have created a new microorganism, a new strand of V. natriagens, which was actually created by combining the two microbes of a previous V. natriagens and an I. sacchensis that can break down polyethylene terephthalate, or PET, which is a very common type of plastic, and much of which is what is polluting our oceans. The microorganism specifically breaks the bond of plastic and can reduce the mass of plastic to about 2% of its total mass in only 48 hours, and only needing the temperature to be 30 degrees Celsius. These byproducts also prove to be harmless to organisms if they somehow do get released into the earth. Scientists are attempting to use these byproducts by preparing recycling plants based off of this microorganism, as well as trying to find another enzyme or organism that will turn the broken down PET byproduct into another chemical product that may benefit the earth. But using these in the electrospinning process would be a much more beneficial use of this in our eyes.
Our solution to the problem of plastic pollution is a solution that will provide lasting results. Our team came up with a solution to leverage a 2-enzyme system comprising a chimera of ice-pedase and ice-medase from Ideonella sacchensis displayed on V. natrigens. We constructed whole cell catalysts that depolymerize PET and convert it into its monomers. By doing this, the plastics get broken down into soluble chemical units, which allow for the plastics to be recycled and form plastics in a closed-looped system without waste. This year at NC State, these microorganisms were created that can break down PET, which is the main type of plastic pollution occurring in our oceans. Our idea will work because we need to save the lives of sea animals. This is an image of me representing what sea animals have to endure with the plastic pollution currently occurring on our planet. This solution will be sustainable for the foreseeable future, and no waste or harm will be done to the environment in the process of recycling these plastics.